Hi and welcome to another video tutorial. In this video tutorial, what I'm going to be doing is talking to you about reverse Polish notation and giving you an introduction to RPN. So reverse Polish notation, it's sometimes called Postfix notation as well, so you may see it being called Postfix. It's a method of writing arithmetic expressions that's easier for computers to evaluate compared to the method that we usually use, which is Infix. So it's easier than Infix expressions for computers to evaluate. So let's go through some examples then of what we mean by a reverse Polish notation or postfix expression, and I'll show you how a computer would evaluate a RPN expression using a stack. So this is an infix expression, which probably looks quite familiar apart from the star representing multiply, but you probably use that in a programming language anyway. And what this is saying is add C to D and then multiply the intermediate result by B, and we get that even though a multiply is more powerful in terms of precedence than a plus, we get that precedence because we've put the brackets in, so we're saying that we want to do the addition first and then we want to do the multiplication afterwards to the intermediate result. If I show you what the postfix looks like, one thing you'll notice is that we've got no brackets in the postfix, and all of our operators and operands are written in a different order. And the way this works is that operators, so in this case the plus and the star, are applied to the two immediately preceding operands. So in this case we get C and D are immediately before the plus, so they're added together, and then we get this intermediary result which comes from this part of the expression, and then this intermediary result and the B is immediately before the star. So we multiply those two together. So how will the computer do this, evaluate this expression then using a stack? Well, first of all, the computer would look at the first token, as they're called, if you're writing a program to evaluate these postfix expressions. Look at the first token, so it's an operator or an operand, and it sees that it is a operand, it's a B. And if we've got an operand, we just push it on the stack. So this is my stack. So it does that first, that's the first step. And then step 2, it's going to read the next token, and it sees that it is again an operand, so it's going to push it on the stack. So if you're not sure how a stack works, then I'd encourage you to watch my introductory video on stacks. And that will give you an idea of how a stack can be used to store data, and how and the operations such as pushing and popping from a stack. Okay, so once we've pushed the B and the C onto the stack, we read the next token and we can see it's yet another operand. So you'll be able to guess what we do now. We push it onto the stack. Okay, so we've reached our first operator when we read the next token, and we can see it's a plus. So what we do when we reach an operator is we pop the previous two operands, or whatever the previous two items are, off the stack. And if we've got our postfix expression right, there should be operands. So the C and the D will be popped off the stack, and then we will apply the operator to those two operands, and then we push the result back onto the stack. So that's what our stack looks like when we've done step 4. We've read the operator, we've popped off the previous two operands that we had on our stack, we've applied the operator to the operands, and we've pushed the result back onto the stack. So now we're going to read the next token in our postfix expression, and we can see that it's a multiplication. And what we do then is we do exactly the same thing as we did with step 4, except we're going to pop the intermediary result of C and D being added together, and we're going to pop B as well off the stack. So we've got nothing in our stack at the moment. We apply the operator to the intermediary result of C and D, and B, and then we push the result back onto the stack. And then when we've done this process, we should be left with one item on the top of our stack, and that will be the result of evaluating that expression. So that's how a computer actually does arithmetic. It uses a stack to evaluate a postfix expression and produce a result. And clearly this infix form is quite easy for us humans to read, and it's what we're all used to, but this postfix form, as you can see, is much easier for a computer to evaluate using a stack. Okay, so I've got this further example here of an infix expression, and hopefully you'd be quite happy to evaluate that if you had values for these operands, and you could work out what P is. What I'm going to show you now is the postfix equivalent of this. Okay, so that's the postfix, and let's see now how a computer would evaluate this postfix and using a stack. So step 1 would be to push P onto the stack, since P is an operand. And we've got another operand next, we've got Q, so we're going to push that onto the stack. We've got a further operand next, we've got W, so we're going to push that onto the stack. So this is our stack at the moment. And then we've got a operator next, we've got a division operator next. So what we're going to do is we're going to pop off Q and W off our stack. We're going to apply the division operator to Q and W, and then we're going to push the result back onto our stack. Next we've got a C, so we're going to push that onto our stack. Next we've got an A, and that's a operand, so we're going to push that onto our stack. And next we've got a multiplication, so we're going to pop the A and the C off of our stack, apply the multiplication, and then push it back onto our stack. Then we've got another operator next, and what we're going to do is we're going to pop the result of C multiplied by A off the stack, and we're going to pop the result of Q divided by W off our stack, and then we're going to apply the addition operator and then push the result back onto our stack. And then we have one final operator, and so we're going to pop the two items that we've got off of our stack, apply the equals operator to our two items that we had on the stack, and then push the result back onto the stack. So we've got our result there. Okay, so that's how a computer would evaluate postfix expressions. What I'm going to do in a future tutorial videos is show you how you can generate the postfix, so go from this infix to this postfix, and also how you can go back the other way. Before I end this video right now, what I'm going to go back to is this step 4. When we came across this operator, the division operator, you may think, well, when we're popping these two operands, the Q and the W, off the stack, what would happen if the computer were to do this instead? We'll get a different result. Well, the default is to always, whenever you're applying an operator, is to take the operand that was the last to be popped off, so this one, in this case Q, and have that as the first operand, and then have the operator, and then have the first operand to be popped off, and have that as the second operand in the evaluation of the expression there. Okay, so I hope you found this tutorial video useful, and thanks for watching.